who are still logging in.
I'm still driving. On top of my car on my camera.
Yeah, if you're still driving, yeah, you're fine. No, some of you didn't live or don't live close, so. The link. Um, All right, let's go ahead and kind of, I guess, take care of a few housekeeping things. Um, so I had to take a little time out to address an email I received from Director Wright. Let me say this about that. The concerns that she had, and of course, I don't want anyone to think that I'm calling you out when I say this, but if you do have any concerns, I would appreciate if you and I, see, this is why this happens. I would appreciate if you guys would go ahead and talk to me first, because when you start getting the front office involved, the situation gets more complicated, and we don't need complicated. I have said certain things regarding the EAQs so many times. I almost feel like my name should be EAQ. So you guys know I've already put it in writing. I've said it in class multiple times. There are too many witnesses that knows what I said about the EAQs, that if you do 20 to 30, then you're fine, you get full credit. I know sometimes in our previous experiences, sometimes we've encountered people who were not very trustworthy, to put it nicely. And so you perhaps think that, well, he might do the same thing, but I can assure you I won't do the same thing. If I told you that I'm going to give you credit for these assignments, trust and believe I am. So don't worry. The reason why I took away all those EAQs and just had you do a limited amount is because I don't want you to be focused on all those EAQs. So what I want you to focus on is reading those textbooks. That's all I want you to really focus on, because then and only then are you going to rise to a level that you didn't realize you had in you. You're not going to get there with doing 200 EAQs, 200 questions per EAQ. So trying to help you out, trying to get you away from that. Besides that, I mean, I can't measure your knowledge by way of EAQs, because in most cases you can copy and paste it into Google and get the Quizlet answer, and then you're done, right? So enough of that. Somebody keeps getting kicked off. What I want you to do is let's go ahead and look at something, or do something that is more meaningful, and that will make a difference in your ability to understand the concepts that we talk about. And the only way you're going to do that is doing what? Reading, right? I really push that a lot, and you get tired of hearing me say it, and I'm going to say it over and over and over again. It is not about EAQs, 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 EAQs. Oh, I just get so tired of hearing about those EAQs. I just want to shoot the EAQs. You know, stop worrying about that. You know, I'm going to give you the grade. I have to do it manually because it doesn't populate automatically. So again, if you have an issue, come to me first. Now, it may not be immediately, but if you know you did the work and it can be proven, then don't even worry about it. Something else I was going to say too. Oh, so there's several times I might mention a thing, or so I may mention something. But with 30 something students, 20 or 30, whichever day I'm dealing with the group. So, every hour, at least for me, I tend to give 10-minute breaks, so you can do your bathroom thing or snacks or whatever the case is. So when I'm talking about some things, sometimes people are kind of in and out of the classroom, and so while you're out of the classroom, I may be talking about something, and then you miss that particular instructions. And I might not have a chance to go back, and then you go or something like that. So I guess what I'm trying to say is wait and go on break and do your business and make sure you're in class during instructions. And that way I don't have to keep repeating myself. You guys don't want me to keep repeating myself because I don't have time to repeat myself a whole lot. You know what I mean? I know some things you have to clarify, and I don't have a problem with that. But if it's because you're in and out of the classroom, maybe dealing with this issue, that issue, whatever issue, you guys got to be present. You all have to be right here in class, focused. Whatever other issues are going on out there in the world, I do understand some of you have children, and maybe they might be sick. You might be dealing with some issues with that, and that's fine. But just know you did sign up for this program, and it does require a certain amount of focus, actually an intense and almost insane amount of focus. So, I mean, it is what it is. Folks hate to hear me say that, but it is what it is. Oh, that's weird. Again, if you're having any issues, then you should talk to me about it, and then we will go from there. Now, I try to send if somebody sends me an email, and I think that it's going to be one of those things where if you got that question, a whole lot of other folks got that question, then I'll just go ahead and send out one whole email. And it might sound like I'm telling you business, but I'm not saying who said what. But I just address it in general, just so that I'm not having to talk to Ms. Barnett individually, and then talk to Ms. Williams individually, and then talk to Ms. Jones individually, and talk to everybody individually. Y'all think I got time for that? I don't have time for that. All right. So some folks feel like if you don't address them specifically and directly, instead of addressing the class, they feel that you didn't address their issue. Come on, give me a break, right? Well, so for example, I'm going to address this issue. All right, this is an issue that came to my attention today, and I also heard something in the background. Well, while I was in the computer lab today, and I just want to make sure I clarify this. And whoever the person is, and I'm not saying who emailed me about it, and I do appreciate the email, but I just want to address the class so that you all won't think otherwise. As far as information that is being given out to the class, everybody's getting the same information. If you're able to access, and you should be able to, the Canvas tile for the courses, then you're getting the same information. The only time you guys might not be getting quite the same information, at least from my mouth per se, is in clinical. All right, so y'all have different, some of you have different clinical instructors. So some of you have Dr. Balance, some of you have Professor Bellamy, and some have myself. And of course, for me, well, all of us actually, we're supposed to talk to you all or have activities and discussions, if you will, in class uh, as it relates to our the topics that we're discussing for your tests. You know, like say for example, fluid and electrolytes, infusion therapy, and what was the other one? Acids and bases. That would you all should have been studying, well, looking at those items for your clinical, right? Not something way out there in some other world, you know, like heart failure or whatever. You're supposed to be dealing with acids and bases, fusion therapy, and so forth and so on. Um, so in terms of getting information, some additional information, I would just say that in my clinical, I'm just discussing the same things that I'm discussing with you all anyway. You know, I do it by way of the PowerPoint presentations and the voiceovers, but I might reiterate those points in clinical. All right, and so the folks who are in my clinical class, they just, I guess you could say they have the privilege, if you will, or the opportunity, I guess I should say, to hear me say it again. But I mean, it's still the same information regardless. But I promise you, you're not getting the different information. Now, I do tend to when I email the class, I use blind copy. All right, and there's a reason behind that. So, not trying to tell anybody's business, but I had someone who did not want their email seen by other classmates, right? And so, because they're a very private person, and yeah, I didn't think nothing much of it personally, but anyhow. And so when I send an email out blind copy, some people might feel like because they can only see their own email, that maybe you know, the information is not being given to everyone. Now, my preference is to use that to section or the CC section when I'm sending out an email. And that way people can see that, all right, so all these people are in my class and we all are getting the same information. All right, so I don't have to think that, you know, I'm getting anything different. I realize that perception can be everything for some of us. And if we feel that we're getting something different, then it can affect us. And I don't want that to affect you. I can assure you, though, you all are getting everything. I don't like a whole lot of variation in my class. All right. Like for example, when I was teaching 1650 days and evenings, whatever I said in during days, I said the same thing in evenings. Whatever I did for days, I pretty much did for evenings as well. So because if I start all this, you know, if I do things differently for each group, that'll confuse the heck out of me. So so I figure since all of you are you might be in different clinical groups, but you're all at 1640. So when I send out information, unless it's maybe a clinical thing, then you all are getting the same information. And even with the clinical, I do document or I post an announcement in the HESI cohort tile, and you all even get to see that. You know, some of you who are not in my clinical, class. So, so you all are still getting that information, but it is for, you know, my group in a way. So, so I hope to dispel, you know, that thought that some of you are getting, or you feel like you're getting different information. Not that is not the case at all. I promise you. If you all were able to access the course tile and you're able to listen to the voiceovers, you're able to read the notes in my PowerPoints, then you got the same thing. Nothing different at all. My goal is to get all of you over the finish line. And I can't do that if I have some kind of preferential treatment going on here. All right, I can't do that. So, so if anybody have any more concerns about that after I've just dispelled that thought, then you can always address me personally again. You may come back and say, well, I still don't believe you. Well, we're just going to have to try to work on that unbelief in some way, somehow, you know. But I can assure you that I'm not about trying to make one group look good and the other group look bad. That just doesn't, it just wouldn't make sense to me. So y'all are getting the same thing, I promise you. All right. Now, there's one thing that we do have to share with the A group. This is one thing that is different because in my clinical, as far as the HESI concepts are concerned, the final HESI concepts, we did look up page numbers. And we were going to share that with you when we came together, which I thought we would be together on campus. And I forgot to do something else with you all. Supposed to let Group A sign the syllabus receipt. So couldn't do that. I should have done that, but I'll do it next time. Anyway, so we did do that. You guys can be doing that too. Begin to look up the page numbers and place them next to your concepts, and that way when the time comes for you to really study those concepts, you'll already know where you need to go to study them. But we had a big class. I think it was like 20, and so we decided to divide it up, and like this person looks up the first two concepts, this other person looks up the next two, and so forth, and then we were going to share that with Group A, since you guys are not with us. B and C are together, but A is in a separate group. Didn't get a chance to do that. I mean, if you all want to even share that offline, that's fine. I did want to provide the opportunity to share that information. Won't be today, of course, but y'all can get with one another and talk about that. That would be very helpful because I don't want to take away class time dealing with those types of things. If I can help it. So anyway, does anyone have any questions? And I'm not offended. Go ahead and put it out there, and hopefully I can answer your concern.
No, I think we're good.
All right. Oh, and another thing I want. You good? Here's another thing I want to say real quickly, and I'm not calling you out. And I guess I am kind of calling you out, but anyway, don't be offended. So sometimes I'm in, let's say if I'm in clinical, and we're having this dialogue going on. So I can see those people who are really engaged and who are really trying to, have this discussion about whatever the topic is, right? So this is why everybody don't get the same thing. I'm still admitting people. All right, so. And I know some of you probably just got home. But I can see those who are engaged while we're having these discussions in our clinical and whatnot. And perhaps sometimes even in a lecture or whatnot. But then I'm looking around and I see these people who are really intense. They're doing something. I don't know what it is. They may be doing some homework or, maybe on Facebook or Instagram or doing something or another, but I know they're not in tune to what I'm talking about. I have seen students in the past that have missed some, a fair amount of questions because I talked about it in class, but they were so involved in something else that they didn't see that or they didn't hear what I said about, whatever the topic was. So what I'm trying to say is you want to fight that temptation to be involved in everything else and be present in the moment. All right. And so if we're having these discussions, we're having them for a reason. I think in my clinical, we had a lengthy discussion about acids and bases. Now, I know who was paying attention and I know who was not. And so when I go back and start looking at these grades and your grade is not up to snuff, then I know you were that individual, or you should know that you're one of those individuals that I'm talking about. So in other words, my advice is, if it's not about what we're discussing, put it down and focus, pay attention. That's all I'm gonna say about that. All right, so let's go ahead and pull up. All right, I'm trying to share my desktop. All right, let me know if you all cannot see my PowerPoint presentation. So you guys got my, well, you should have received my announcement where I talked about the topics that we'll be discussing. For those of you who can see, if you can do me a favor, people will probably be coming in either later or they might be getting kicked off. If you guys don't mind, because when I'm in a share mode, I can't.
We're gonna add
Thank you. That's what I'm talking about. That's what I'm talking about. All right, yeah, because that some of you have don't have the best connection. So let me show you this quickly. So for those of you, modules.
Hey, Dr. Weaver.
Yes.
Is there a link for this class? Because a few students can't get in.
They can't get in?
No.
Do you guys know how to go to your the calendar portion of your Outlook?
Yes, that's what we do. But there's this one particular student whose Outlook is not working, so she doesn't get school emails.
Oh, that's not good.
Yeah.
I guess you don't want to tell who it is, but yeah, they need to let me know that, because if they're not receiving emails, who knows what they're missing.
Well, it's true that, but she doesn't get these emails and stuff. But I have no idea how to go ahead and send her that link because there's no link.
Let me see.
Can you send like a link and maybe I could forward it to her personal email or so?
Yeah, let me join on your computer. There used to be a way that oh, you know what? Maybe that's copy link. No, open. There used to be a way that I can make sure you guys just come straight in without being admitted. And for some reason, this system doesn't allow me to do that anymore. So anyway, let me see if I can find. It doesn't do that anymore. I want join. Add to join. No, that's not it. Copy link. Was that, how do you pronounce your name? Who was just talking? The student who I was just talking to, who was just telling me about the other student. What's your name again?
Oh, that's Nikki.
Nikki?
Yes.
What's your last name?
Abraham Howell.
So you were just telling me about the other student who doesn't have email?
Yes.
Let's see. And, oh, you know what? Now see, when you say Nikki, I'm thinking Nikki.
No, it's Nikki.
You're gonna have to let me know that now. That because that's pretty unique. So NG.
Dr. Weaver,
Yes.
there's a number they could call. There's a number they could call in
Yeah.
instead of using the link. If you go to your calendar, I can't access mine because I'm still driving. If you go to the calendar under the link, it's gonna give you. I think it's a 913 number.
You know, I saw that. But will they be able to see? I don't think they'd be able to see the presentation though.
Oh, well, that's true. Or also,
I mean,
Nikki, you could go back to your calendar and copy the whole thing and send it to her, and she could open the link through that.
Okay,
yeah, I just sent it to Miss Howell.
Okay.
Miss Howell, you'll send it to her.
Yes, I'm gonna. check right now.
I guess I'll just go ahead and do that with the whole class then, just in case,
Okay.
just to make sure. You know what? As a matter of fact, let's see, 23.
Okay, forward to.
All right, do not.
Okay, I'm forwarding that to her, and if she doesn't get in, then there's nothing I could do.
Yeah, well, it's already sent. It's, you know, anyway, if you guys are in situations where you cannot get an Outlook and whatnot, you really need to let me know and perhaps talk to Ben so he can straighten that out, because one of my main methods of communication is via email. And if I'm not communicating with you or you're not receiving my communications, you're going to be at a loss.
Sure.
And I don't want you to be at a loss. So we really need to communicate. Don't feel, as folks like to say, a certain kind of way. So it must be, all right, so it must be this person. Yeah, don't feel, a bad way, so to speak, just because you may be having some problems. I mean, if it's not you, it's probably somebody else. So, all right. So take a look at the module. So the first one here is inflammation and immunity, integumentary system, pre, intra, and post-op care. And this is in a module 3, week 3. And so this is what your quiz would be on next week. Now, I have not had a chance to do a voiceover on any of these. I will probably end up doing it on, well, if I can get to it. But they are full of information. So for example, if I go under integumentary, and you all have access to this, if you lift up, and I don't know, some of you may not have been doing this, so you don't think you have it. But if you lift up the 3 ellipses, all right, somebody just came in. If you look at the ellipses here, there's like these 3 dots, and you look at the notes. Here are the notes on everything, all right? And the notes are pretty in-depth, right? It's everything you need. Nobody should be lacking in anything, all right? I said something here. So what is that about? Oh, for example, when you see something here that says covered in term 7 about regarding bites and stings, that means don't worry about that, all right? Because in term 7, you will get this. So I discovered as I was going through these presentations that some of them are like burns. Burns is covered in depth in term 7. So I'm not going to cover the same thing that somebody else is covering, because that just takes away from other topics that I can, spend some time with you all. So yeah, things like that, don't worry about. Anyway, so those are your notes, and I take copious notes, so nobody should be lacking by any means, right? You read those notes, you should be fine for my test. Quizzes, tests, whatever. So that's how you get to that. So as you know, I won't be able to cover everything, and this is why I do a combination of notes and voiceovers and so forth. So, but what I would like to do is to cover something that I find that students can kind of struggle a bit with. And so I thought immunity and inflammation would be that topic for this week. And so we'll have a discussion about that. So let me go ahead and see if we can get started. So I hope most of you are in, if not everyone, those who can join. All right. So we'll be discussing again inflammation, immunity. This can be it can be a bit of a challenging topic because there's so many different components to the immune system. It's not as difficult as you might think it is, though. But you really have to, you have to put the work in it, obviously. Right. 3. Make sure you take a look at your priority concept, which is immunity here, and that is what we're discussing. So everything it just goes right back to immunity. So just just consider that as we have this discussion as well. All right. Now, so as it has been, somebody else just came in. As it has been described in chapter 2, immunity is essentially protection from illness, disease that is maintained by the body's physiologic defense mechanisms. So one of the main, I guess I can say, visible defense mechanisms we have is what? Can anybody tell me one of the main defense mechanisms we have? Something we all can see when we're looking at each other.
That's skin.
Skin.
Exactly. So this protection requires interaction of immunity and inflammation. And there's a difference, and we'll go through that. There's a difference between immunity and inflammation. Inflammation is mostly a local event, whereas though immunity involves all these, it kind of captures inflammation, but more so your immune cells, like your white blood cells, the different white blood cells, and whatnot, antibodies and antigens and so forth. So it's when we're talking about immunity, it just encompasses a whole lot more, which again we will get into all that. So this protection does require the interaction between both the immunity and inflammation working together in order to control infection and other problems caused by those harmful microorganisms or those cells that are altered. And when we talk about altered cells, just think in terms of your own cell that is abnormal. It may be a cancer cell, or it may be a cell that is infected by a microorganism. While we also discuss this, I need you all to think about what is it? Think about microbiology as well. Some concepts that you may have learned that you have learned in microbiology, we will also include that in the discussion as well. Now, again, so components of immunity include, as you just said, the intact. So that's the key, the intact skin. Because once the skin is broken, then you no longer have that whole intact defense system. Also think about the mucous membranes and many different white blood cells and their products as well. It's all a part of the immune system. And so we'll be hitting on those areas as well. Now, in addition to being protected, immunity also plays a role in how our tissues are repaired from damage. When you get a cut, on your skin somewhere, let's say on your arm, eventually, if your immune system is working properly, then that area is going to be healed. And the immune system plays a role, especially your white blood cells, in this particular effort. Now, infectious diseases are common, but most adults are fairly healthy, and they don't fall ill. So, but these microorganisms are all around us, right? Immunity with inflammation is critical to maintaining health and also preventing disease. So again, both of these, they work hand in hand. One cannot work well without the other. When all the different parts and functions of immunity are working well, then there's a concept that you all should be familiar with, and that is immunocompetent. Now, there's another term that is opposite of that. Does anyone know what that is?
Immune deficient.
Yeah, you can. Yeah, what's the other one though? I like that one, but yeah, there's another one. Think of the word.
Immunosuppressant.
I like that one too. What about immunocompromise? All right, so you hear both. You hear all those terms, so that's good. You're able to pull those terms out as well. So immunodeficient, immunocompromised, and what was that other one? Immunocompromised, deficient, suppression. Yeah. So, but yeah. So immunocompromised, immunocompetent. So we all want to be immunocompetent. Our immune system is competent. Now, immunity is reduced by many diseases, lupus, rheumatoid arthritis, and the like. Also by injuries, especially when organisms can gain entry into our bodies by way of some kind of wound, if you will, or open skin. And also medical therapies. Think about the immunosuppressant medications that patients receive, that like for organ transplants. You don't want your immune system to attack that organ, and so we put them on immunosuppressant medication so that we're basically weakening their immune system so that it's not powerful or strong enough to attack those organs, those solid transplanted organs. And there is some discussion in this presentation, which whether I get to it or not, that talks about organ transplants, and it's pretty straightforward. So you have a chance to take a look at that as well. By the way, again, this will be your next quiz, and it will be open book, so we will be virtual next Thursday. So whether immunity is reduced temporarily or permanently, this reduction always endangers your patient's life when you think about it, because even if whatever the situation is, let's say if it's an injury, and if the immunity is reduced because of that injury, it's only during that time, rather, of that injury until the patient begins to heal, then you're at risk of some really major issues. All right. Now, immunity uses many cells and their functions to fight against the effects of any injury or invasion. Somebody just came in. Adults interact with many other large and small living organisms, be that bacteria, viruses, molds, spores, pollens, protozoa, and also cells from other people or animals. Right, so our immune systems is always up against these types of organisms, small or large. Now, body defenses to prevent organisms from entering obviously include what we just said, the skin, the mucous membranes. But also we talk about the microbiome, which is basically the normal flora, whether it be on the skin, inside of our mouth, and our intestines and whatnot. For example, in the intestine, the normal flora for that area is E. coli, right? I mean, even though that bacteria is there, but it's all our immune system always keeps it in check. And it's not until our immune system is compromised that then there's an overgrowth of E. coli causing disease. So we all have some of these microorganisms already a part of our system, just like the skin. On the skin, there is streptococcus and also staphylococcus as well. But it doesn't cause a problem as long as we have an intact skin and our immune system is working properly. Right? We have these natural chemicals that inhibit bacterial growth on our skin as well. Now, most of these invasions, they don't result in disease or illness because, again, as long as our immune system is intact, then we should be good to go. All right. Now, immunity and the immune system stimulate processes to neutralize a microorganism, to eliminate it, and also to destroy those invading organisms. So this is what the main purpose of the immune system is all about, is to neutralize it. You know, when we neutralize the enemy, think about these organisms that are not a part of our system as an enemy. And your immune system is essentially that the Army, the Air Force, the Navy, the Marines, the police, and the National Guards, and so forth. So think about your immune system as such. And so their job is to neutralize, eliminate, and destroy anything that would destroy innocent people, if that makes sense. So to protect without causing harm, immune system cells exert actions only against non-self proteins and cells. And what that means is immune system, if it's doing its job, then it should only attack what is not a part of our own system. But of course, you know, we have to think about autoimmune disorders, meaning, you know, the body, our defense systems are working against its own cells. So those are your autoimmune diseases, which is what we're not talking about at the moment. But our immune system is supposed to fight against non-self. Someone just came in or trying to get in. Now, immune system cells, they can distinguish between the body's own healthy cells versus the non-self proteins or cells when everything is working right. All right, and this is just an image of when we talk about self versus non-self. This is what the immune system is going to go after, right? And before we even get to it, I will tell you that it's what we would generally refer to as an antigen. All right, so the antibodies are produced to attack the antigen. All right, so that's what it's all about. When they actually immunize you or anyone else, they're putting an antigen inside of your body. And so your immune system will develop these antibodies that will attack it. And of course, your immune system will remember it. So that if it happens again, you know, like people, if they get a COVID, you know, if they get COVID, or rather if they get a COVID injection, your immune system will mount an attack against that antigen. And then if you come in contact with someone with COVID again at some point in time, your body will have a way of, your immune system has a way of remembering that particular antigen, and then it will attack it, and then you won't get the disease, hopefully. You still can, but under certain conditions. So it's not 100%. Now, non-self proteins and cells include infected body cells. It can be, you know, like if your cell is infected by a virus or bacteria. So there are proteins that are on those cells, right? It can be a protein, it can be infected body cells. It can be those cancer cells and cells from other people or invading organisms, right? They are proteins, and see, it is the proteins that are located on these abnormal cells that the immune system actually recognize. All right. Now, recognizing self versus non-self is a term we call self-tolerance. All right, self-tolerance. And this action prevents immunity from harming healthy body cells. We don't want our immune system to attack our own body, as you see in autoimmune disorders, such as lupus. All right. Now, self-tolerance is possible because of the different proteins that are present on cell membranes. All right. So when you look at these cells, well, let me use this one. So look at this red one here, the non-self cells. So you have these proteins on the cell membrane. And so this is how your immune system is able to identify if it is friendly versus an enemy. And so in this particular case, non-self cell, the protein that presents itself on the surface of the protein will be considered enemy. It would be considered enemy. Now, cells are surrounded by plasma membranes with different proteins on or through the surface area. So this would be like your plasma membrane, this membrane that surrounds all of these internal structures of that of the cell, right? And then this is where they're talking about you have these proteins that are on the cell membrane, all right? And another example, many different protein types are present on liver cell membranes. And each of these protein types differs from that of all other protein types. Now, each person's cells have unique surface proteins that are specific to that person, and we call them human leukocyte antigens, or HLAs, as an abbreviation. All right. We also refer to these as a universal, and don't get all caught up in a lot of these terms because it'll become a little more clear as we go further into the discussion. But these HLAs, or human leukocyte antigens, serve as a universal product, a code for that particular person, and are identical only to HLAs of an identical sibling. So, in other words, if you're talking about identical twins, then their HLAs are going to be the same. And so the immune system, let's say if you were to receive, whether it be a blood transfusion or an organ or something like that, your identical twin that you donated that organ to will have the same HLAs, and then your immune system will not attack it. All right, and that's dealing with identical twins, not fraternal, but identical siblings or twins, if you will. Otherwise, if you're just talking about different people, then the HLAs or the human leukocyte antigens will be different. All right. Now, one adult's HLAs are recognized as foreign, and that's what I'm saying, or non-self, by the immune system of another adult. So if you try to put your system's, let's say, cells into my body, then my body is going to recognize the HLAs which are located on your cells as unfriendly, and my immune system is going to attack it. It's no different than a donated organ. All right, so I received someone's kidneys, and it has these HLAs on the cells, and so when my immune system interacts with those cells, and it becomes known that, well, you're not a part of, this person's, makeup, if you will, then I'm going to attack it. And this is why those patients, they tend to reject those organs. And this is another reason why discussing the immune system is so important, because you guys are going to be encountering a lot of patients with organ transplants. I mean, and what way can we tell if somebody has had a transplant? Can anybody tell me?
If they're on immunosuppressants?
Exactly. You can know a lot about a patient if you didn't look at any other information and all you did is just looked at their list of medications, provided they've been treated for any most of their issues. If you look at their medications or the person's medication list, it can tell you a lot. So somebody's on a beta blocker or an antihypertensive, a medication that this patient probably has high blood pressure, and you can infer some other things as well. But at least just basically you can pretty much tell what they're on. So with these transplanted patients, which you will run into quite a few. I mean, they're doing transplants, heart transplants, lung transplants, pancreatic transplant, renal. So they're doing all these transplants, and these patients are going to be on immunosuppressants unless there's an identical twin, obviously. Now, because the cell surface proteins are non-self to another adult's immune system, right? Because then when I receive cells from you, there's going to be a protein on the surface of that cell that my immune system is going to recognize that as not a part of our system of the system of the individual. It is known as, again, an antigen. They are antigens, which are proteins that are capable of stimulating an immune response. So when you see that protein on the surface of that foreign cell, it's referred to as an antigen. The antigen is what's going to cause our immune system to create antibodies. And it is the antibodies that will launch the attack. All right, the army is going after the enemy, the antigens. All right. Anybody have any questions about this, what I just talked about?
Dr. Weaver.
No.
Yes. Yes.
Can you hear me? Because my phone keeps breaking up. I'm trying to listen and I'm on the phone.
Sure.
You said you could tell that they're on some type of drug because of the medication. That's what you said?
For the most part. For example, you can see a patient on prednisone. Well, prednisone alone doesn't necessarily mean somebody has an organ transplant, because somebody who's an asthmatic can be on prednisone. But let's say if somebody's on Prograf or cyclosporin or some of these other immunosuppressant medications, which I do have some of those listed as well in here, so you'll be able to look at those. But if you see those medications, once you learn it, because right now that's why you're here, your job here now is to learn these things. And then when you go out into the practice setting and you see these medications, then you'll be able to say, oh yeah, that patient must have a transplant. And of course, when you read their history and physical, you'll see that this patient was a kidney recipient. You know what I mean? They had a kidney transplant, liver, or whatever the case is. That makes sense?
Yeah.
Did that answer your question, though? I'm sorry.
It did.
All right. So those HLAs that I talked about, the human leukocyte antigens, they are antigens. They are what are recognized by the immune system and That's what brings about the production of the antibodies, which we'll talk more about antibodies, hopefully, here shortly. All right, and these are the proteins on the human cell membrane here. And this is what is recognized by our immune system. All right. These other structures that you see, like the plasma membrane, this is what surrounds those cells, and these other different structures, like the receptors and what have you. They're there for a reason as well, and we'll get into that as well as we move further in the discussion. But basically, some of our immune cells, our white blood cells, they can attach themselves to those receptors and unleash an attack, on them. So, but that's just a nice depiction. A nice depiction of that. All right. Now, human leukocyte antigens, as I mentioned, are on the surfaces of most body cells, not just the leukocytes, but on most body cells. They are a normal part of the person and determine the tissue type of a person as well, which is coded for the specific gene this person inherits from both parents. So even when they do tissue typing, they're able to see these antigens as well. Right. Now the HLAs of the human leukocyte antigens are a key for recognition and self-tolerance, because this is what the immune system is going to come in contact with to determine if it is self or non-self. Now, the immune system cells constantly come in contact with other body cells and with any invaders that enters the body, and this is what we want. We want the immune cells to come in contact with everything, because we need to identify: do you belong? Do you not belong? All right. Now, at each encounter, the immune system cells compare, all right, the surface protein HLAs to determine whether the encountered cell belongs in the body. So when that immune cell comes in contact, when I come in contact with you, and you don't have on the same lab coat, the same name tag, you don't have the same whatever we use to identify whether or not you're part of this organization, then we're getting ready to take you out, so to speak. So it does this comparison, if you will. Now, if the encountered cells HLAs match the HLAs of the immune system cell, then the encounter cell is a self, and you would not, or the immune cells won't attack it. All right. So the immune cells have its own HLAs, and then when it comes in contact with another cell and it evaluates the HLAs on that particular cell, and if it's not the same, the fight is on. We're getting ready to, knock down, drag out, whatever. So if the encountered cells, HLAs, do not perfectly match the HLAs of the immune system cell, the encountered cell is non-self, or we refer to it as a foreigner. It doesn't have a passport. I guess that's a good way to put it. It doesn't have a passport. And so it leads to the immune system cell then would take action to do what? To neutralize, to destroy, to eliminate this foreign adversary. So very intricate system, as you can see. Now, a key element for recognition of non-self by cells, it does involve it involves general immunity, which we'll discuss even further, and those involved in specific immunity is the presence of what we call toll-like receptors on these cells. So these cells have what we call toll-like receptors. Now, toll-like receptors, they resemble what we call toll receptors, and they're known to be present on immune system cells of humans and other animals, as well as on defensive cells of insects and plants as well. All right, and their protective purpose is to interact with the surface of any invading or foreign organisms and allow recognition that it is not self. So actions are taken to rid the body of this invader. So in other words, so these receptors, they just basically come in contact with all of our cells, and they evaluate them. And if they're not of the same sort or same protein, if you will, then its job is to neutralize and to get rid of it. And this is what protects us from illness. Now, these toll cells also help immune system cells recognize damaged or unhealthy cell cells. So not just those microorganisms that we know don't belong, but also cells that did belong, but now they are unhealthy, like cancer cells, or cells that are damaged for whatever other reason. It tends to recognize those as well. All right. Now, immunity does change, and this is very important for you to know, because you guys will be as nurses, the population that you'll deal with mostly will be the older population. All right. So this section that I'm dealing with here just deals with older adults and how their immune system deteriorates over time. And so they don't react to, the immune system doesn't react to these foreign invaders compared to, folks in their 20s and 30s and whatnot. I don't know how that happened. That's weird. So immunity changes during an adult's life as a result of things like nutrition, there's environmental conditions, drugs, disease, as well as age. Right? Now, immunity is more efficient when we're younger, 20s, 30s, and whatnot. But as we get older, then you're pretty much on the decline. And this is what opens us up, especially when you get in like your 40s, middle age and whatnot, 50s, and you become more susceptible to cancers. And yeah, kind of a sad, reality, but some of you who are pretty young right now, you're in your 20s, maybe 30s, you'll begin to see your, people you've grown up with, people when they reach their 40s and 50s, that they begin to die of things like cancers and whatnot. Because as you get older, your immune system, it does decline. Now, older adults have decreased immune function, which increases their risk for many health-related problems. For example, they have reduced neutrophil function, and the neutrophil is a white blood cell. Neutrophil counts, they may be normal, but their activity is significantly reduced. All right, so they have the number, but they don't have the power and strength to do what they used to do. And of course, this will increase this patient's risk for infection. There's also a term called leukocytosis. When you see leuko, the tosis on the end of these words, it means an increase in this amount of white blood cells, as opposed to leukopenia. The nia would be a reduction in white blood cells. But in this case, leukocytosis involves an increase in white blood cells. All right. So leukocytosis does not, in older people, does not occur during an acute infection. All right. and it would be so you won't see this particular change in your older patients. All right, and so this patient can have an acute infection, and because the white blood cells don't readily increase, which will give us a sign or show us that this patient is having a problem, an infection and whatnot, then it causes us not to be able to react timely. Because we do use your CBC, which contains your white blood cells, to determine if someone is having an infection. So anyway, so leukocytosis does not occur during acute infection. So patients may have an infection, but not show those expected changes in the white blood cell counts. So does anyone know the range for white blood cell count? And this is very important. Can anyone tell me? Right. So 5 to 10K. And so it may still be 9K and they have a really significant or severe infection. But in older people, it just doesn't respond as readily. So in other words, what I'm saying is don't automatically assume that because they're white blood cells. Yes. Yes. Can you hear me?
I just had a question. Yeah, I can hear you. I just had a question. Like, if you have like cancer or something like that, not every time will your white blood count be elevated, right?
Well, if you have, let's say, are you saying if someone, let's say they have cancer and they're getting treatments, cancer treatments?
No, they're not getting treatments, but they have been diagnosed with stage 4 cancer, and their white blood, they get a physical every year, but their white blood cell count has never been elevated.
That's possible, except, for example, if you have leukemia. With leukemia, your white blood cells would be like through the roof. Your white blood cells can be 100K or more. Instead of between 5 and 10, it could be as high as 100K or more. And but here's the problem: those white blood cells in that particular case are not mature white blood cells. They're immature white blood cells. All right, and immature white blood cells cannot launch an effective assault against an invading organism. Right. So though even those patients, you may have 100K white blood cell count, but you're susceptible to infections, septicemia, and so forth. Make sense?
Yes, yes.
So you can have stomach cancer, but that doesn't necessarily mean it will show in your white blood cells, because the thing about your white blood cells, it typically increases in the event that there is an infection, but not all the time. Sometimes when patients are on steroids, it also increases their white blood cells. They don't have an infection, but it can show an increase in their white blood cells. And so, but once you start titrating the steroids, then the white blood count will come down. Yeah. Yeah. So anyway, so once you begin to titrate the prednisone down, then you should see the white blood cells come down. But your white blood cells, in the presence of steroids, it'll cause that increase. Now, so again, you guys have to make sure that that when you're dealing with your older adults, that just because, I mean, they may be showing some other signs of an infection. Is that somebody talking? So Don't assume, is what I'm saying, that they don't have an infection. They can have some other things going on, and the white blood cells are not that much elevated, but just know that it's because of their age, and they're more or less on that decline, right? Also, older adults may not have a fever during an inflammatory or infectious episode. Um, so not only is there potential loss of protection through inflammation, but also minor infections may be overlooked until these patients become more severe or severely septic. Then you might see then you should see the white blood cells or the immune system responding. But by that time, how late is it? It's all about timing, and we want to catch things a whole lot sooner. And so, because we have this knowledge about our older population, then we can kind of, make plans to where your physician, they can put some measures in place to protect these patients. Now, also, those of you who have heard of the type of white blood cell called a T lymphocyte, so the number of circulating T lymphocytes, they also decrease with these patients. And so, and that sets them up for infections as well. So, like when you get the TB test, your T lymphocytes actually is what attacks that antigen that, the tuberculin solution. That's the antigen, and your T lymphocytes, they tend to attack the antigen, and of course you get this local reaction on your skin. And so, because these older patients, they have a decreased circulating T lymphocytes, they cannot mount an attack as readily, and therefore they may have a negative skin reaction. It doesn't mean they don't have tuberculosis, but their immune system just cannot respond to that antigen. So in other words, with this one, you might want to go ahead and still place that patient on isolation, right? Because the skin may not react, and you may not have the sputum specimen or culture back yet, but yet the patient might be coughing up blood, right? Or a chest X-ray, which is, these things are more readily available for the most part. Or chest X-ray may show some cavitation in the lung tissue. So you want to go ahead and place those patients on isolation, because otherwise, all these people who go into those rooms are now in contact with someone who has, a TB. Let's see. Yeah, so I did that one. All right, now the immune system is present throughout the entire body. All right. Most immune cells come from the bone marrow. And we know that the white blood cells are certainly from the bone marrow. Some cells will mature while they are in the bone marrow, and others leave the bone marrow and they mature at other sites in our bodies. All right. Now, when they are mature, many immune cells are released into the blood, where they circulate to most body areas, and they have a specific effect in those areas as well. Now, the bone marrow is the source of all blood cells, red blood cells, white blood cells, platelets, and so forth, including most immune system cells. Now, the bone marrow produces immature, what we call immature, undifferentiated cells called stem cells. So, in other words, so your bone marrow, they create these cells, they're immature, and you can't tell the difference of what they're going to become. All right. Those cells can become a red blood cells, it can become a platelet, it can become a white blood cell, or any type of immune system cell. So we refer to it as a stem cell for the time being until it's differentiated, until you can determine what that cell has become. Now, stem cells are what we call pluripotent. And what this means is that each cell has more than one potential outcome. It can become any cell type. When the stem cell is first generated in the bone marrow, again, it is undifferentiated and not yet committed to maturing into a specific cell type. So right now it's in that indecisive stage, if you will. Now, this stem cell is flexible or pluripotent. It's flexible, and it can become any one of mature blood cells, especially where there's a need. Because if one of these immature cells come in contact with, let's say, erythropoietin, which is a hormone produced by the kidneys to produce red blood cells, then that red blood cell, or excuse me, that cell that you couldn't tell what it would become will become a red blood cell, so that your patients don't become anemic. Actually, I didn't even see that. But so the maturational, the ability for it to take a certain path to mature of any stem cell depends on, again, the needs of your body at that time. You may need more white blood cells. It may need more platelets so you don't bleed to death. White blood cells so you don't have an infection. And so in this case, the presence of certain specific growth factors, erythropoietin is one. I think leukopoietin is another that deals with platelets. But I gave you the example of erythropoietin, which is a growth factor type of hormone that causes one of those cells to become a red blood cell, and then you don't have anemia. Now, when the immature cells, stem cells, are exposed to whatever the growth factor is, it can become that. Now, white blood cells, or also called leukocytes, are the immune system cells that use a variety of actions to provide immunity. And you can take a look at table 17.1. Table 17.1, it lists the functions of different immune system cells. Right. Now, the leukocytes, or white blood cells, provide protection through certain defense actions. So, and what is that? There's this recognition of self versus non-self. So we talked about that. That's one of the things that it does. One of the functions, defense actions. There's also destruction of foreign invaders. We know the white blood cells do that. There's also cellular debris. All right, some of those cells that have been damaged, they become cellular debris, kind of useless, if you will. And also unhealthy or abnormal self cells. There's also production of antibodies directed against those foreign invaders. So this is what leukocytes, what their jobs are. So they have a variety of functions. Now, there are three processes that are needed for human protection through immunity. All right, and there are three. One being inflammation, the other being antibody mediated immunity, or AMI, or cell mediated immunity. And again, don't get all crazy, and I don't want your eyes going in the back of your head as you hear these terms. We'll talk about these different concepts. But just know that in order for us to have good protection, all these processes must be working together. Inflammation, antibody-mediated immunity, which we'll discuss, and cell-mediated immunity. Each process uses different defensive actions, and each influences or requires assistance from the other two processes. So they cannot work individually, but they must work together. Therefore, full immunity or immunocompetence requires the function and interaction of all three. Otherwise, compromise. I hate that. This is just where I just talked about stem cell differentiation and maturation. And essentially those undifferentiated cells that have not committed to any particular cell, and this is just an image for that. Kind of a nice depiction of what we talked about. And this is just the bone marrow, because most of our cells are made from the bone marrow. White blood cells, red blood cells, platelets, and some immune cells as well. Now, when we talk about general immunity is non-specific, and it is also called innate, native immunity, or natural immunity. All right. So with inflammation, general immunity provides immediate protection against the effects of tissue injury and invading foreign proteins. Right. So this is where, when we talk about, let's say if someone has an injury, let's say a cut, or they got stabbed, then this is when general immunity and that local inflammation will come into play to protect the individual. Now, this innate native immunity is any natural protective feature of the human being. It is a barrier to prevent these microorganisms from entering the body, and they can also attack these organisms that have already entered the body. So this is why we need this natural immunity, or this innate native immunity, just in case something has gotten past the first line of defense. So we still want to take care of the enemy. Now, the inflammatory responses, the skin, the mucosa, the antimicrobial chemicals that is located on the skin. We also talk about natural killer cells, and also complement. Complement is also not like you compliment someone, but there's a concept called complement that is a part of the immune system as well. So don't get all caught up in that either. But just know that all of these elements, they work together to provide us that general immunity. All right, skin, mucosa, antimicrobial chemicals on the skin, the complement part of the immune system, and NK, or natural killer cells. It makes up general immunity. Now, inflammation is critical for our health. And general immunity and inflammation, they differ from specific immunity in two ways. Inflammatory protection is more immediate. Like when you get cut or stabbed, that inflammatory protection is immediate, because we need the white blood cells to race to that area. We need to clot it off. We need to fight locally there in case any organisms are trying to enter into our bodies. It is short-lived, but it is more immediate. It doesn't provide what we call true immunity, all right, on repeated exposure to the same organisms. That's when we get into more of the complex part, like the cell-mediated immunity that we discussed earlier, or I think the other one was the antibody mediated type of immunity. But this particular type of immunity, it just protects you from this particular problem if you get stabbed. All right. It's not like on repeated stabs, you're immune to these organisms because it's just different each time you become injured, if you will. Now, inflammation is a non-specific body defense to invasion or an injury, and it can be started very quickly, almost with any event, regardless of where it occurs or what caused it. So inflammation triggered, let's say, by a scald burn, you were burned to the hand. It is the same as an inflammation triggered by bacteria to the middle ear, for example, right? So how widespread the symptoms of inflammation are depends on the intensity, the severity, and duration of exposure to that initiating event. So if it's like a minor type of, let's say, cut, then the symptoms of inflammation will be smaller, on a more smaller scale. But let's say if somebody got burned, let's say 50% of their body, then that inflammatory response is going to be much greater, right? Involving the entire body as opposed to that local area. So that's what that depend on. Now, inflammation starts tissue actions that can cause those visible and uncomfortable symptoms that are important in ridding the body of any of those harmful microorganisms. All right. So that pain, that throbbing, the redness and all that you see as far as inflammation is very uncomfortable, but that's the inflammatory process that is visible and that's at play. All right. But your body is trying to, well, it's not necessarily repairing at the moment, but it's trying to reduce the amount of injury locally in this instance. Now, so if the inflammatory response is excessive, all right. Now, when we think about the inflammatory process, we look at it as being helpful to that local injury, if you will. The problem is if the inflammatory response is if it's exaggerated, because sometimes our immune system would do this, when it becomes more exaggerated, more severe, then tissue damage will result. And it would be very visible. I mean, I developed, I don't know if it was an abscess from an ingrown hair, that apparently the inflammatory response was much greater. And of course, I have a nice scar to prove it. But we want that inflammatory process to occur, but we don't want it to be over exaggerated because you'll be able to see the tissue damage involved in that case. Now, inflammation also helps. Once inflammation starts, it also kicks off this antibody-mediated or cell-mediated actions in order to activate that full immune system response. All right, and so that's what we talked about. They all work hand in hand. Inflammatory or inflammation, antibody-mediated and cell-mediated, they all work together. They cannot work independently. All right. Now, inflammation occurs in response to, of course, tissue damage, as well as to infection by organisms. Now, this will probably confuse people because when you hear the word inflammation, you automatically think infection, right? So infection is usually accompanied by inflammation. So usually if you have an infection, then you're likely to have some inflammation. But inflammation can occur without an infection, all right? So an example of that would be if you think about inflammation without infection, think about a joint sprain. think about a myocardial infarction or a blister or something like that. There's inflammation, sure, right? But it doesn't mean that there is an infection, all right? Now, inflammation caused by non-infectious invasions also include allergic rhinitis, contact dermatitis, and also other allergic reactions. There's inflammation, but not an infection. So inflammation does not always equal infection. All right. Now, the leukocytes, and of course, you know, we're talking about white blood cells. Involved in inflammation are your neutrophils, your macrophages, your eosinophils, as well as your basophils. You all should have heard about this in anatomy and physiology and also microbiology as well. Right. Now, there's an additional cell type that is important in inflammation, is the tissue mast cell as well. Now, your mature neutrophils, which is again a white blood cell, it makes up about 55 to 70% of the normal white blood cell count. Right. Now, neutrophils come from the stem cells that we talked about, you know, before it becomes differentiated. But neutrophils do come from the stem cells, which are located in the bone marrow as well. And they do complete that maturation process in the white blood, in the bone marrow. That's where they become mature. They are also called granulocytes because of the large number of granules that are present inside of those cells. Right. Now, the less mature neutrophils are called band neutrophils. Bands or stabs because of their nuclear shape. These are just different types of white blood cells. Now, usually growth of a stem cell into a mature neutrophil requires about 12 to 14 days. That's kind of the turnaround time before they become more mature. Now, this time can be shortened by the presence of specific growth factors, such as a cytokine that we'll discuss later as well. So if cytokine is a growth factor as well, or hormone growth factor. And so when cytokines are released, it can cause these neutrophils to mature a whole lot faster. Some of those growth factors are what we call the granulocyte macrophage colony stimulating factor. These are certain drugs that you can be given as well to stimulate more white blood cells. And also granulocyte colony stimulating factor, or GCSF. These are different medications you give these patients, especially your cancer patients might receive some of these drugs. Now, this huge production is needed because the lifespan of each neutrophil is pretty short, about 12 to 18 hours, not days, but hours. And so you really do need a large amount of these, this particular type of white blood cell for protection. Now, neutrophil function provides protection after invaders, especially bacteria, into the body. So when a bacteria or some invader into the body, the neutrophils begin to act. Now, this powerful army, if you will, of small cells, it destroys invaders by what we call a process of phagocytosis. And I would imagine you all have heard about phagocytosis, where the white blood cell engulfs the microorganism. And then when it engulfs it, it uses an enzyme, a digestive enzyme. It's called the enzymatic digestion. All right, so you engulf the cell and you release that powerful enzyme onto that organism, microorganism, and you destroy it, right? So each cell is small and can take part in only one episode of a phagocytosis. So that's just each cell. One cell can't, impact many, but just the one. Now, mature neutrophils are the only stage of this cell capable of phagocytosis. All right, so not the other cells, but the mature neutrophils are capable of the phagocytosis in this case. Now, because this cell type causes continuous, constant, and non-specific protection against organisms, the percentage and actual number of mature circulating neutrophils are used to measure a patient's risk for infection. So the higher the numbers, the greater the resistance to infection. All right. And this measurement is what we call the absolute neutrophil count, or ANC. The thing about the ANC is if the absolute neutrophil count is very low, these patients are said to be neutropenic. And so we have to place them on isolation. So we do depend on a certain number that will provide us with protection. All right. Now the differential of a white blood cell count shows the number and percent of the different types of circulating leukocytes as well. And you can find that information in table 17.2 as well. Now, most circulating neutrophils are segmented neutrophils. Only a small percentage are what we call band neutrophils, or less mature forms. And typically, if we refer to them as bands, then they are less mature. And sometimes during infection, when the body is trying to get rid of the invader, the microorganism, these numbers will increase significantly. And when that happens, you'll see a lot of white blood cells, but they are actually immature. And because they are immature, these patients are set up for, or they are susceptible to infection. Now, problems such as sepsis cause the circulating neutrophils to change from being mostly segmented neutrophils, meaning mature neutrophils, to being less mature forms. Right? Now, this situation is referred to as a left shift, or bandemia. When you hear left shift as it relates to white blood cells, or bandemia, because the segmented neutrophils that are located to the far right, are no longer numerous. There's not an increase in the segmented type. But what you will see are the immature types, and we refer to that as a left shift. It just deals with the white blood cells. A right shift means they're mature, and left shift means that they're immature and that they will be many. And so when they're many like that, they cannot fight infection or microorganisms effectively. So, so instead of having more of the circulating cells, or instead more circulating cells are bands of the less mature type of cells farther to the left on the neutrophil pathway. And these patients can still become infected, even though the white blood cell count may be pretty high. It's called a left shift, and you will hear that again as you matriculate through this program. Now, a left shift indicates that the patient's bone marrow cannot produce enough mature neutrophils to keep pace with an ongoing infection. And what it's doing is releasing all these immature neutrophils into the blood. All right, it's kind of like, you know how when you're on a job and you're short as heck, and you don't have enough help to help do the job, And then hiring all these people, and it takes let's say it takes a whole month to train these folks, but yet they're putting them out, and after 3 days they're putting them out there, and of course you see it because they're very ineffective. There's a lot that they don't know. There's a lot that they can't do. So same thing in this case. The bone marrow is trying to just put out all these white blood cells in order to try to combat the infection. Only problem is they are immature. These immature cells are of minimal benefit because they are not capable of what? Phagocytosis. They can engulf and release that enzymatic, those enzymes, enzymatic substance to destroy the microorganism. Left shift, people, left shift. Don't ever forget it. Matter of fact, I think that's probably one of your concepts for next term. All right. Now, there's another white blood cell site. Excuse me. There's another kind of tongue tie. There's another white blood cell called macrophages. Macrophages come from the committed myeloid stem cells in the bone marrow. All right. So when this particular stem cell becomes more mature, it comes from the myeloid, stem cell in the bone marrow, and form what is called the mononuclear phagocyte system. All right. Again, don't get all excited about some of these terms. Not trying to make immunologists out of you all, but you have to have some knowledge about it, of course. Now, the stem cells first form what we call monocytes. This is before they become macrophages. But so from the stem cell, they form monocytes, which are released into the blood at a certain stage. Until they mature, monocytes have limited activity. Until they're actually needed, they have limited activity. Now, macrophages function help stimulate immediate inflammatory responses. It also stimulates the longer lasting immune responses of the antibody mediated immunity and also the cell mediated immunity. So we need the macrophages, they just extend that inflammatory response in this particular case. Macrophage function includes what? Phagocytosis as well. Also, they help in repair. They also help in antigen presenting and processing. And what that basically means is that it helps to present that antigen that's on the cell surface of that foreign invader. It helps to do that because once it presents it and it becomes recognized, then we're in that process of neutralizing and doing away with that organism. And it also it acts in a way of secreting cytokines for immune system control. And we'll probably get into cytokines further into the discussion as well. All right. Now, the inflammatory function of macrophages is phagocytosis as well, just like in neutrophils. It is also involved in phagocytosis. Macrophages can easily distinguish self versus non-self. And their large size makes them very effective at trapping those invading cells. So those invading cells just can't get by your macrophages. They have long lifespans, unlike your neutrophils, which are like what, 12 to 18 hours? Well, your macrophages have a much longer lifespan, and each cell can take part in many phagocytic events. So remember with your neutrophils, they can only take place in one phagocytic event. But your macrophages, because of their characteristic size, they can participate in many events. So that's what makes them different. So you have that comparison. They both do phagocytosis, but yet they differ in how long they last, and some of their other functions as well. Now, the other white blood cell is referred to as a basophil. Basophils come from myeloid stem cells as well, and they make up only about 1% of the total circulating white blood cell count. Remember, the neutrophils make up the majority, 55 or more percentage, but basophils are much lower, 1% of the total circulating white blood cells. Now, these cells cause the signs and symptoms of inflammation. What you see at that local site, this is what basophils, this is what why you see those symptoms at the local site. It's because of basophils. Now, so what do basophils do? Basophil function acts on blood cells with the basophil chemicals. And these are what we call vasoactive amines. In other words, they can cause vasoconstriction of blood vessels. And they also have basophils, they bring about heparin, histamine, serotonin, kinases, and also leukotrienes. All right. Now, some of these you may have heard before, for example, your leukotrienes. All right. And all a part of this inflammatory response that you see. And so some of your drugs that these patients take, they prevent this basophil function, which means that inflammatory response, it reduces it. All right. And so again, don't get caught up in a lot of these terms, but these terms are essentially important in that local inflammatory response that you typically see. All right. Now, so for example, heparin. Heparin inhibits blood and protein clotting. All right. So that's why that particular substance is brought to the site at some point. Then you have these histamines. Your histamines, they dilate your arterioles and they constrict small veins. And just think about it, if they dilate the arterioles, it's because they're bringing nutrients to the site, right? So the constriction, it slows, it slows blood flow, all right? And causes more decreased venous return. And this effect causes blood to collect in the capillaries as well as the arterioles. Now your kinases dilates, and this is what this is what they're doing locally. The kinases, as far as the substances that are released by the basophils, they dilate your arterioles, and it also increases capillary permeability, causing blood plasma to leak into the interstitial space. And of course, this is when you'll begin to see swelling or edema. So they call it, it's what's called also a vascular leak syndrome. Now, basophils stimulate both general inflammation and also inflammation of allergic reactions. So it's involved in both. Involved in general inflammation as well as allergic reactions. The next white blood cells is called eosinophils. Eosinophils come from the myeloid line as well, and they contain many vasoactive chemicals as well. Now, only 1 to 2% of total white blood cell count is composed of eosinophils, so it's not many of those either. Now, eosinophil function is most active against infestations of parasitic larvae, and also it limits inflammatory reactions, especially allergic type reactions. Now, the number of circulating eosinophils increases during an allergic response. So if there's a need, then you'll see a greater increase in the number of eosinophils, right? And then the last one, I think is the last. So the last cell that is involved in the inflammatory or immune process is what is referred to as tissue mast cells. Now, tissue mast cells look like, and they have functions that are very similar to our basophils and eosinophils. All right. Now, although mast cells do originate in the bone marrow, they come from a different parent cell than compared to your leukocytes. And they don't circulate either. They don't circulate as mature cells. Instead, they differentiate and they mature once they get to our body tissues, especially those near blood vessels, lung tissue, skin, and the mucous membrane. And all this you're hearing for the first time because a lot of you, I'm pretty sure, you did not have a chance to read this information before I went over it. So for the time being, just kind of sit back and just kind of take it all in. I'll also go ahead and post this particular video so you can just listen to it again. And even if I don't finish everything now, let's see, so I'm on slide 11, it's 12:20. So we'll probably get to at least slide 12. And so I'll just finish up the rest of it later and then I'll post it and then you'll have the whole thing. So don't worry about that. All right. Now, remember when I talked to you guys about the complement system being a part of the immune system? So the complement system is a part of innate immunity, right? It is a part of the immune system. And it is composed of a system of 20 different types of inactive plasma proteins that when these plasma proteins are activated, they act as enzymes, right? When we think about enzymes, I automatically start thinking about a destroyer because enzymes are very powerful substances. And what they do is they attract certain agents or they enhance the complement process in order to try to, basically destroy the organism. So anyway, we don't want to get all tied up with that, but just know that the complement system is a part of the immune system. The immune system can get very complicated, I'm telling you right now. And right now, you guys are just not at that level where you need it to be that complicated. But just know it's a part of the process. I do provide you all with some focus sheets. And so whatever you need to know about some of these components of the immune system, then I'll give you an idea of what that's about. Now, this is that phagocytic or phagocytosis process. And take a look at number one, exposure and invasion. Then there's that attraction step. It attracts the microorganism. Then it adheres to the microorganism. Number three, then it recognizes it. It looks at it. It recognizes it. Oh, you're not the same, right? And then number five is that cellular ingestion. It attaches it to it and it releases those enzymes to destroy it. Then you have that phagosome formation. They're getting ready for some phagocytosis. Getting to the end, of course. And then that degradation begins to destroy it. So that's a nice kind of depiction of what that looks like. Now, a key process of inflammation is the phagocytosis, the engulfing, and it engulfs, right? And destruction of invaders, which also rids the body of debris after tissue injury. So phagocytosis also removes those debris. Once tissues are destroyed and becomes debris, in other words, unuseful, then this phagocytic process can remove it from the body. Now, neutrophils and macrophages are the most efficient. They're most efficient at phagocytosis, as we just learned. And as you can see here, phagocytosis involves about 7 steps, and this is figure 17.6 in your book if you want to take a look at this as well. Pretty much the same thing, though. Now, exposure and invasion occur as the first step in response to injury or invasion. Attraction is the second step, and it brings the white blood cell into direct contact with the target antigen or invader or foreign protein. Then you have adherence. Adherence binds the phagocytic cell or your macrophage and your neutrophil to the surface of the target. Now, recognition occurs when the phagocytic cell sticks to the target cell and recognizes it or not. So in this case is what we're talking about now, it doesn't recognize it, so you all know what's getting ready to happen. You're an enemy. You're not supposed to be here. You don't have a passport. So then you have your cellular ingestion occurs when the target cell, that invader, the target cell, is brought inside the phagocytic cell, so it's engulfed, right, by phagocytosis. And then when we talk about phagosome, formation occurs when the phagocytes granules, you know, those granules that you see inside of the neutrophils and well, particularly the neutrophil, they break open because what's inside of those granules are enzymes. And once those granules break open, they release those enzymes, and the enzymes will attack the target cell or the enemy to destroy it. And so degradation is the final step. The enzymes in the phagosome digest the engulfed target, and of course at that point you get rid of it, and then you don't get an infection, hopefully. Does anyone have a question about that? I think your book really explains that very well. Phagocytosis. All right. Now, you all should be familiar with this slide. Whenever we talk about, let's say, inflammation, and especially that local inflammation, that local injury, these are the 5 cardinal manifestations of inflammation. I don't care if it's a cut on your head, on your hand, on your toe, it doesn't matter. You're going to have a typically warmth, redness, swelling, pain, and decreased function. And all of these manifestations of inflammation are occurring because of the inflammatory process, especially locally speaking. All those white blood cells, those cytokines, they're releasing all these chemicals and everything, and it's causing all these symptoms. And this is what I was talking to you guys about. If that inflammatory process becomes exaggerated and more severe, then these symptoms are more severe as well. And so this is why we give these patients sometimes like NSAIDs or like Motrin or what have you, or these anti-inflammatories to calm down the inflammatory process. Now, inflammation or the inflammatory responses occur in predictable 3-stage sequences. The sequence is the same regardless of the wherever it is, the injury. Now, responses at the tissue level cause these 5 cardinal symptoms of inflammation that we just mentioned. And so the timing of the stages, they might overlap sometimes. It's not in like warmth has to be completed before redness, and redness have to be completed before swelling. Sometimes they might overlap as well. So. All right. Now I'm going to go ahead and continue with slide 14, just so I can kind of finish this part off. I could actually stop right here, but I'll keep going until I finish this part off. And then those of you who want to get off at 12:30, you can, but I'm going to finish this part. And then later on, I'll go ahead and do a voiceover on slide 15 through, I think, 21. There's like 21 slides total, but I'll finish off 14 and finish up to 21 later. Then you'll have this for your reference to review. Oh, you know what? But before I do that, for those of you who need to get off, let me go ahead and put the QR code up in case you want to sign out. So I am going to, let's see. What was that? I'm sorry, I couldn't hear you. That's A, by the way. Oh, well, you know what? Oh, I'm sorry. What's your name? Who's driving? I can probably sign you out. Oh, is that Miss? You know what?
I voted out too because I can't sign out because I'm on my phone.
I'm still driving. Can you sign me out?
So that's Miss Phillip. All right, hold just a minute. Some of you who I need to sign out. Let me go ahead and share this first for those who can scan out. So this is A. So you all go ahead and sign out for A. Whoever needs to leave.
Can you sign me out?
All right. Hold just a minute. What's your name again?
Brandy Cruz. I'm in Group A.
Brandy. Let's see. So hold just a minute. So did everybody get out? Who can get out on A? All right. So I'm coming out of this real quick. Coming out real quickly.
I was trying to log out.
All right. Let me put it up again. Go ahead. This is A, and I'll get the other ones manually. If Miss Cruz. Is Miss Cruz on?
Yes, sir.
Did you say you were driving?
I'm watching you on my phone, so I can't take a picture of the code.
Oh yes. All right. All right. So hopefully, all right. So that's A, and then all right. So Miss Cruz.
Me as well. I'm in A. It needs to be clocked out. I'm Hayes.
And who is that?
Hayes.
Anjana Hayes.
Yes.
All right. Let's see. Wait a minute, folks. Wait a minute. What about Malia Kynes? Is she on? Malia Kynes. All right. So I don't know if she's on, but since you all have to sign out at this point, I go to sign that one out. Miss Knight, are you on? Selena Knight. I thought I saw her name up here. Miss Knight, Selena Knight. You know what? I don't know if I can see her.
I need to be signed out also.
And what's your name?
Whitney Hampton.
All right, I'm on. Oh yeah. All right, I don't know why they have Professor Davis on here. Isn't that crazy? It's not a male in this class, is it? No male in this class. Selena Knight. I thought I saw her on here.
Professor, can you sign me out?
Say again.
Can you sign me out, please?
And what name is what's your name?
Alina Hagan.
Alina. What group are you in?
B.
All right, so this is A. I knew I saw. Let's see. All right, wait a minute. That's only one person.
Professor, could you sign me out, please?
You know what? Wait a minute. This person is not here. This Jenica. I don't think they're in this class. And this one isn't either. This Rojas Guzman. I don't think they're here either. All right. Let me pull up B. And so those of you who are on B, go ahead. B and C, go ahead and sign out, and then I'll go ahead and do the other ones manually.
How do you sign?
Well, if you have a QR code, well, if you listen to me on your phone, then you probably won't be able to do it. So just kind of hold off a minute. But those who can scan out, go ahead and scan out.
Okay. Kane on the phone.
Yeah, if you're on your phone, just give me a moment.
Okay.
All right, and I'm going to hide this. And so what about Miss Alberti? Alberti, are you on?
Yes, I'm on. I'm gonna see where we find out real quick. 1 second.
Are you on your phone or are you on a computer?
They let me find out. I did it already.
I'm sorry, can't hardly hear you.
I found out already.
Oh, all right, all right. What about Miss Kaylin? Miss Kaylin Barnett?
Yeah, I'm on my phone. If you could sign me out, that'd be great.
All right. What about Miss Dial? I thought I saw her coming in and out.
Yeah, she actually said driving and she lost service and wasn't able to get back on. At some point, she actually texted me and told me to let you know.
All right, great, great. And what about Miss Hagan?
Yes, sir.
All right, so you're on your phone too, right?
Yes, sir. I'm still in the car.
All right. What about Miss Hall, Frances Hall? I don't think she was in class today. I don't think. Maybe not. So Miss Hall, what about Miss Heath?
Yes, I'm on my phone. I need you to sign me out, please.
And I know Miss Johnson is not here. What about Mrs. Langree?
I'm driving. Can you sign me out, please?
Sure. And Miss Sierra. Who's that?
Linda Heath, you heard me?
I think I got that one, didn't I?
Yeah, I just wanted to make sure you hadn't said anything.
Yeah, that one is signed out. Miss Muhammad, Miss Sierra Muhammad. Did anyone see her on? She's the one with the braids, right?
Yes.
And I don't see where she was on. Well, I see her name here. Miss Muhammad, can you hear me? I don't know if that's in the inactive section. Oh, that's invited. I know Miss Muslet is out. What about Miss Philippi? Philippi? Are you driving?
Oh.
Were you able to sign out, or are you driving?
No, I'm on my phone.
You're on your phone.
Yes.
All right. So I just signed you out.
Okay, thank you.
But what about Miss Walker? Brittany Walker?
I need to be signed out. I'm driving.
Man, we really had to be creative today, didn't we?
Yes.
Lord. Well, all is not lost. You know, we're doing our thing. So. All right. I think that's pretty much all who were here.
Dr. Weaver?
Yes.
Hi, this is Jamila. When can I come in and take the exam?
Let's you and I talk offline about that. Do you have my number?
No, it's on Canvas, isn't it?
Yes, it is.
All right, I'll take it.
What time did you sign on?
I didn't sign on. I'm with Linda.
You never signed on? Or not signed on, I mean, or what time did you get on this call, I guess is what I need to know.
Linda was here since the beginning. I was with her when she got on.
So you got on about what time then on this virtual?
So, no, not 12.
Probably about 10.
10 o'clock.
About 10?
Yeah.
About 10.
10 something, maybe. I don't know, a little after 10. I don't know. Go around, stupid idiot.
Leave those people alone.
I thought I was on mute, girl. My bad.
No, you're bothering those people. All right. All right. So I think that's everyone. All right. So let me go ahead and just finish up this last slide, and at least I don't have that much to go later on. So that's a good thing. All right. Oh. All right, so in this last slide that I will go over for now, this is just dealing with the sequence of the inflammatory response. And so inflammation or inflammatory response, this does occur in a predictable three-stage sequence, process. So again, the sequence is the same as I mentioned earlier, no matter where the injury is located. So in stage one is a vascular response that starts with changes in the blood vessels, right? And so injured tissues and the leukocytes and tissue mast cells in this area secrete histamine. See, remember those histamines? Histamine, serotonin, and kinines that constricts the small veins, and they dilate the arterioles. Now, remember, arteries bring nutrients, oxygen, nutrients, minerals, and so forth. So one is bringing, or the arterioles are bringing the nutrients for healing and whatnot. Now, these changes, because of this, these changes cause the redness and the warmth of the tissues. So remember we looked at the 5 cardinal signs. So when you see redness and warmth, this is how this happens. All right. Now this increased blood flow increases delivery of nutrients to the injured tissue. Remember, we needed to heal. Now blood flow to the area increases, or what we call hyperemia. All that excessive amount of blood flow to the area from the arterioles. What it causes is edema. So edema forms at the site of the injury or invasion. This is where the swelling comes from because of the increased blood flow. Now, capillary leak also occurs, allowing blood plasma to leak into the tissues. And this response causes swelling and pain. And when you think about the swelling, all that swollen tissue compresses nerves. And of course, you have pain. Now, There's a purpose also for edema. Edema protects the area from further injury by creating a kind of insulation or cushion of fluid. Now, the duration of these responses depend on the severity of the initiating event, but it usually subsides within about 24 to 72 hours. All right. The macrophage is the major cell involved in stage 1 of inflammation. Now, the action is fast because macrophages are already in place at the site of injury or invasion. Remember I said that the monocytes don't fully become macrophages yet, but they're kind of traveling in the bloodstream and they settle in certain spots throughout the body. And so this action is limited because the number of macrophages are very small. So unlike neutrophils that are many, macrophages are not as much, but they do pack a punch. They have a great responsibility. Now, to enhance the response, tissue macrophages also secrete several cytokines. And of course, cytokines, they have that function as well. So again, so the tissue, to enhance the response, the macrophages that we talked about, they do enhance several of the cytokines that we'll talk about in more depth as well. All right. Now, some cytokines are kind of a messenger. They're these kind of hormones, if you will, that exerts their effect on other tissues, other cells. They kind of make other tissues and cells do things that are helpful, that can be helpful in the inflammatory process. It's kind of like the endocrine system. So, you know, like you have, you might have the, in the posterior pituitary gland, the ADH. So ADH is basically is stimulated from the posterior pituitary gland that is all the way up here near the head or the hypothalamus, but then it sends the ADH hormone to the kidneys to absorb or reabsorb water. All right. So your the cytokines are kind of those messengers that travel to different parts of the body, and it brings about a certain action, if you will. All right. So some cytokines cause neutrophils from the bone marrow to move to the site of injury or invasion. So you see what cytokines are doing. So if the macrophages secrete these cytokines, then some of these cytokines are even having this influence over neutrophils and saying, hey, neutrophils, come to this site. We need you. We need more help, right, in this area. All right. And of course, once the neutrophils move to that site of the injury, this will now lead to the next stage of the inflammation, which will be stage 2. Now, in stage 2 is the cellular exudate part of the response. So in this stage, neutrophilia, or where there's an increased number of circulating neutrophils. Remember, neutrophils were attracted by the cytokines, and so they're now increasing in number or circulating in number will occur. Now, you know how sometimes when you see pus at the injury site, so exudate, which is pus, is a form of pus that occurs. And this exudate contains certain substances like dead white blood cells. It contains necrotic tissue and fluids that escape from those damaged cells. This is the consistency of pus. Now, neutrophils, basophils, and tissue mast cells are active in this stage or stage 2 as well. Now, under the influence of cytokines, see, cytokines are kind of like the they're kind of organizing things, you know. So, kind of want you to see it in that way as well. they're bringing about whatever activity is needed during this immune process. So under the influence of the cytokines, the neutrophil count can increase significantly within 12 hours after inflammation starts, right? Now, neutrophils attack and destroy organisms and remove dead tissue through phagocytosis. Remember, we talked about phagocytosis. In acute inflammation, the healthy adult produces enough mature neutrophils to keep pace with this invasion, and they prevent the organism from growing within the human body, right? And so then we have this enzyme called COX, or cyclooxygenase. Now, this is very important. What you all are getting ready to hear, because with this enzyme, cyclooxygenase, converts amino acids into chemicals, into these chemicals that further process into these substances called mediators, or that they promote continued inflammation, right? So remember we talked about that inflammatory process, and well, all this pain and redness and swelling and all this activity from the immune system. So where I talked about the enzyme cyclooxygenase, this is why they give these patients NSAIDs, because NSAIDs, it actually stops this process, this inflammatory process. And if you can stop the inflammatory process, then you have this decrease inflammation, such as the redness, the pain, and the all these symptoms that you see, those cardinal manifestations of inflammation. And that's why I was telling you that when we're talking about the enzyme cyclooxygenase, think at this point it's one of the functions of NSAIDs, of like your Motrin, your Aleve, and whatnot. It's just kind of calming down this inflammatory process. All right. When this particular enzyme is unchecked, it is processed into these different mediators, such as the histamine, the leukotrienes, the prostaglandins, the serotonin, and the kinases, right? And so again, these substances that I just listed, this is what is causing this. Can be an exaggerated inflammatory process. All right. And if we don't want that to occur, because it's very uncomfortable, it's very painful, then what it's kind of a cascade. One event is happening after another, bringing about this process. And again, so we give these patients these anti-inflammatory drugs to stop this cascade, preventing this cyclooxygenase from converting amino acids into inflammatory mediators. This is what we don't want. I mean, initially, the inflammatory process is good, but then after a while, it can become so exaggerated that then it begins to, or the inflammatory system begins to destroy even good tissue. All right, and so the anti-inflammatories will calm down that cascade effect. And hopefully you guys, if you can't really quite understand that now, just go back and continue to listen to that. Just like the ROS system we talked about, the renin-angiotensin aldosterone system, we're given an ACE inhibitor or an ARB to intervene or to stop that multi-step process that can be very damaging to the heart. So in this case, in order to stop these mediators, histamine, leukotrienes, prostaglandins, serotonin, kinases, in order to stop this process, we're going to give a Motrin, and the cascade is prevented from further destruction and injury. Now, when an infection stimulating inflammation lasts longer than just a few days, the bone marrow begins to release, remember we talked about this, immature neutrophils. So if that inflammatory process lasts longer than it should, then you'll see an increase in these white blood cells or increased bands or a left shift. And this will reduce the circulating mature white blood cells, and we don't want that because this will set these patients up for a sepsis as a result, right? And so now then we go into the third and final stage, which features tissue repair and replacement. So although this stage is completed last, it actually begins at the time of injury, and it is crucial to the final function of the inflamed area. So white blood cells involved in inflammation start the replacement of lost tissue or repair of damaged tissues by inducing the remaining healthy cells to divide, all right? In tissues that cannot divide, the white blood cells will then trigger a new blood vessel growth, and also scar tissue will form as well. And this is in that last stage. This is when your scar formation will begin as well. So because scar tissue does not act like normal tissue that it replaces, it really does not have much in a way of a function other than maybe a patch, if you will. A good example is when heart muscles are destroyed by a myocardial infarction, such as a heart attack, scar tissue will form in that area in order to prevent a hole from forming in the heart wall. Because remember, ischemic cells, they do die, and it becomes necrotic, and they can develop a hole. And so scar tissue develops. So you have this scar. The scar tissue just serves as like a patch. It doesn't contract, and it doesn't act the same way as regular heart muscles react. So if, let's say, 20% of the left ventricle is replaced by scar tissue because of the heart attack, the effectiveness of the left ventricle is going to be reduced. It won't be able to contract about 20% of it. And so again, that's the last and final stage. And so just giving you kind of an example with that. Now, inflammation alone cannot provide long-lasting immunity. So this is why we start talking about the cell mediated and the antibody mediated immunity, all right? Lymphocytes are the cells needed for long-lasting antibody mediated immunity and the cell mediated immunity, which that's what I'll talk about when I come back. So what we just talked about more so was the inflammatory process, but then there's also an immune processes that must take place in order to bring about, immune protection for like when you get exposed to an organism, let's say influenza or some other disease, virus, bacteria. Well, you need these other two types of immunity so that one, it can recognize it, because we also create what we call memory cells. And it is the memory cells that recognize these invading organisms that, hey, I remember you, right? And then it'll begin to attack those cells because our immune system has a way of remembering an antigen that it has had contact with before. But we'll get into all that when I come back to starting with slide 15. All right. Let me come back here. So anyway, at this point, I would say we are going to conclude this portion of the lecture. Again, as I told you earlier, I will finish this up. I'll go ahead and post it, and you can take a listen to it. I'll see if I can possibly do a voiceover on some of the, maybe one of the others. I'm just not sure. If you have, when you come to my 1650, you'll see that there's quite a few of my voiceovers that are already done. So it is a process. The main thing is that you all get my written notes, and that way you know what you're being assessed or tested on. So, but I'll try to get to it as much as possible. There's just so much to get to at this point. Does anyone have any other questions before I sign off, before we all sign off?
No, thank you.
All right. All right. Well, look for the other one later on then.
Thank you.
All right. You all have a good one.
You too.
Thank you.